Alright, this lesson is about similar triangles. We're being asked to figure out if two triangles are similar and write a similarity statement. Let's look back for 1 second. There are three different ways to prove that two triangles are similar. One is side-side-side similarity. If all three pairs of sides are proportional, that just means they're going to all make the same ratio if I make fractions out of them. For example, 10 over 5, 10 and 5 are corresponding sides, and if I do 10 over 5 as a ratio, I get 2. 6 and 3 are corresponding sides, and if I do 6 over 3, I get 2. 12 and 6 are corresponding sides. If I do 12 over 6, I get 2. So this is what it means when I say all three pairs of sides need to be proportional. So that would be side-side-side similarity. By the way, these three ratios that all turn out to be the same, this is called the scale factor. So we would say the scale factor is 2. Alright, and in this context that means that the big triangle is twice as big as the small triangle. Anyway, in addition to side-side-side similarity, we can prove that two triangles are similar if they have two angles that are the same. Like 65 and 30, the small triangle has degrees 65 and 30. That's enough to prove that these two triangles are similar. And the third and final way to prove that two triangles are similar is side-angle-side similarity. The S and S again refer to the sides being proportional. So I mean, I used the same number, so we've already done the math, but these are still proportional, meaning that the 10 over 5 equals 2 in the same way that if we've got the 12 and the 6, again 12 over 6 equals 2. So we have two pairs of sides that are proportional and then one angle that is congruent. It's important that the angle that is congruent is between the sides that are proportional. So that gives us our side, angle, side. If this 30 degrees in here were somehow on a different angle, so if I took this 30 degrees and put it over here, for example, these two triangles would not be similar. Even though I have two sides and an angle, and here I have proportional two sides and an angle, it's the wrong angle. Okay, even if the 30 on this triangle were also moved. Okay, even if this 30 were also over here. Still, these two triangles are not similar. We cannot be sure that they are similar. Okay, it has to be two proportional sides and the angle that's between them, not the angle that's off to the side. Okay, so that's the background knowledge that we need to be able to do this. So keep that in our mind. As we state if the triangles are similar, I'm going to be looking for, do they have which type of similarity? Do they have side-side-side? Do they have angle-angle? Or do they have side-angle-side? I'm going to be watching out for that. Alright, looking at problem number 1, we have two pairs of sides. We don't have any angles that are given to us. So this makes it very likely that we're shooting for side-angle-side similarity. But of course we need that angle in the middle. And this would be the angle in the middle. And we do know that those angles are congruent because they are vertical angles. Anytime you have intersecting lines, the angles that are across from each other are congruent. They're called vertical angles, and vertical angles are always congruent. So you should mark them. So I do have, I'm given a side, an angle, and a side, and I'm given a side, an angle, and a side. That doesn't mean I can automatically say, oh, these triangles are similar by side, angle, side. I have to see if these sides are proportional. So I have a choice. I can try doing the 16 and the 39 together. So I'm going to try that first. Okay. So say if I want to see if the 16 and 39, maybe these are corresponding sides. So if I try that, then I'm going to have, I'll just go ahead and do 16 over 39. Okay, that can't be reduced. Alright, so that's that side. But then, you know, we can kind of already see it, but I'm going to follow through. If I look to see if these two are corresponding, if these are proportional. If they were proportional, it would make 16 over 39 again. But of course, it makes 16 over 40, which would reduce. But I can already see 16 over 39, 16 over 40. That's not the same. So, so far, that's a no. But there's one other possibility that we have to try. Maybe they're proportional with the sides going diagonal. So for example, I've got this 16 here. Maybe the 40 would be a corresponding side. So let's try that instead. Okay, so if I go 16 over 40, okay, that's 2/5. Okay, so if I'm going diagonal with it now, now I'm going to try to see if this 16 is going to correspond with this 39. Well, you know, that's the same, it really is the same situation that we had before. You know, I'll just to follow through. So if I tried diagonal, so this would be 16 over 39. So I had 16 over 40. Again, I see the 16 over 39. It's really the same situation. This doesn't simplify. They're not equal. So either way I tried it, I could not get the sides to be proportional in any pairing. So this is a no. These triangles are in fact not similar. Alright, let's move on to problem number 2. I have the 3 lengths given. So since the 3 lengths are given, I'm shooting for side, side, side. So if these are going to be proportional, I need to find the fractions need to be all giving me the same result once simplified. Now, it might be helpful to go by size. Okay, 72, 84, 48. What's the biggest? 84 is the biggest. Okay, I'll circle that in blue. Now, 12, 14, and 8. What's the biggest? 14 is the biggest. So I'll circle that. So this will help narrow things down for us, so we don't have to do so much trial and error. If these triangles are going to be proportional, if they're going to be similar, then the 84 and the 14 are going to have to be corresponding sides, the biggest and the biggest. So let's try that out. So let's see, where should I put this stuff? So I'm just going to go left over right. So if I go 84 over 14, I get 6. Okay, so if these triangles are going to be similar, I better get 6 every time. Okay. Now, looking at the left triangle, the smallest side is 48. Looking at the right triangle, the smallest side is 8. Alright, so if these triangles are going to be similar, these should be corresponding sides. So let's go ahead and try 48 over 8. And this is one of our multiplication facts, so we do know that this is in fact 6. So far so good. Let's do our last one, the 17 and the 12. I mean 72 and 12. So the 72 and the 12 would need to be corresponding sides. So if I do 72 divided by 12, of course I do get 6. Okay, so that means all three pairs of sides are proportional. So these this will be similar by the side similarity. So we will go ahead and say yes, these are similar because of side. Okay, so yes, they're similar, that's why. And now we can go ahead and say our triangle similarity. So look, so we're going to say triangle. Now we have to make sure the angles match. So look at angle C is right here. So here's angle C. See how angle C is between the blue and the red? Over here, angle F is between the blue and the red. So angle F is the matching angle, the corresponding angle. On the other hand, angle A is going to correspond with angle H. I guess I should have done angle B next. Angle B is going to correspond with angle G. So since I have angle B next, I'm going to put angle G, and then I have angle A, so I'm going to put angle H. The order does matter. Alright, let's move on to number 3. Alright, that one was a no. Okay, number 3. I have a pair of sides, and I do know that vertical angles are equal. So I have a side, an angle, and a side. So let's shoot for side, angle, side similarity. Let's use the shortcut. One of my students named Grant suggested this all on his own. So let's follow through on that and look for on this triangle between the 14 and the 8, 14 is the biggest. So looking at this triangle between the 49 and the 28, 49 is the biggest. So if these are going to be corresponding sides, if the triangles are going to be similar, these would have to be the corresponding sides. So I'm just going to do left over right. So let's go ahead and do 14 over 49. So if I do that, that's going to reduce down to 2 over 7. Now looking at the other pair of sides that we're given, the 8 and the 24, if I again go just left over right and do 8 over 28, okay, if I reduce this, 4 goes into 8 twice, 4 goes into 28 7 times. Alright, so I get 2 over 7 both times, so both pairs of sides are proportional, and of course I've got the angle in the middle between them, so they will be congruent by the side angle side similarity. So I can say yes, these are congruent because of side angle side similarity, and now I can make my similarity statement. So triangle. Obviously angle V is going to be the same here, so but in other news, okay, so we have angle V is going to be the same for both. So angle V is first, so let's go ahead and put angle V. But next they have angle U. Okay, So looking at angle U over here, okay, see how that's next to the blue? So that's going to be like angle L over here. So angle U is next, so angle L is next. And then T is last, so that means angle M is last. Okay? Let's take a look at number 4. Now, looking at these markings mean that these angles are the same. Angle U is congruent to angle K, and angle T is congruent to angle J. Right there, that tells me that these triangles are similar because of angle-angle similarity. So immediately we will say, yes, these triangles are similar by angle-angle similarity. Obviously, they've been sort of rotated around, but that's okay. So this one's pretty straightforward. So we can go ahead and state the similarity now. They have angle J first. Well, angle J has a single mark. Angle T has a single mark, so T goes with it. Okay, angle K is next. K has a double mark. U has a double mark, so U is next. And then they have angle L. So we're going to go ahead and put angle V. That's the only one left. So that's number 4. Okay, that's pretty straightforward. Now, angle number 5. This one seems unusual because in the triangle on the top, I have a double mark and a triple mark. Then in the bottom, I don't have any marks that are the same. So, and I don't have any side lengths. I'm just not seeing any possible way that this is going to be anything. I don't have any sides, so I can't do side-side-side similarity or side-angle-side similarity. And I have angles marked, but none of them are marked congruent. You know, the only ones that I know are congruent for sure are this angle right here and this angle right here. But one angle of congruence is not enough. We needed 2, and we just don't have it. Okay, so moving on to number 6. Okay, this is going to be a little bit hard to see, and I might have to redraw it for some of you to see. These triangles, there are 2 triangles that are overlapping. And, okay, one triangle is the more obvious one. It's triangle KBC. It's like this. Alright, so there's triangle KBC. Now the other triangle is the bigger triangle, triangle KLM, and it looks like this. Okay, so our job is to see whether or not those 2 triangles are similar. So to help you see it, I'm going to go ahead and split them apart for you. So there's the bigger triangle, and here is the smaller triangle. So we're trying to see if these are similar or not. Let's see if I can zoom in a little bit. Okay, so triangle KBC is right here. Here's K and B and C. Now this bigger triangle is KLM. So this is K and L and M. Okay, now looking at what we're given, on KB is 16, and then KC is 25, so we have that. And then KL, they have it marked already for us, is 88. And then KM, it looks like we might have to do some adding of our own. So it seems like this 107 is just this little piece over here, CM. So we have to add the 107 and the 25. Okay, so together that makes 132. Okay, so KM is 132. Now, so we have 2 sides for both triangles. So there's no side-side similarity. So we don't have three sides, so we can't do side, side, side. If we had the angle in the middle, we could shoot for a side-angle side similarity. Is there any way that we know that these angles are congruent? Well, here's a hint. This is angle K in both cases. Of course, an angle is going to be congruent to itself. And if you look back in the picture, you see that angle K is shared by the small triangle and the big triangle. It's the same angle in both cases. So of course that angle K is going to be the same both times. Okay, so they are congruent. So we have a shot at side angle side similarity. That's what we're going for. We just have to check and see if the corresponding sides are proportional. In this case, it's pretty obvious which two we are shooting for, and it's we've got the 88 and the 16 would be corresponding sides. So let's check that out. I'm just going to do left over right. So if we do 16 over 88, okay. So 16 over 88, you get 2 over 11. Okay, and so now let's try the 25 and the 132. If this gives us 2 over 11, then we will know that the triangles are similar. Let's take a look. 25 over 132. But that does not simplify. Okay, so we had a good shot at it, but in the end, the corresponding sides were not proportional. Okay, if they had both made 2 over 11, it would have been side angle side, but they didn't. So this is a no. I'm kind of disappointed, to be honest with you. I was kind of emotionally invested in it. It's weird. Anyway, let's move on to number 7. I think I'm too zoomed in now. Alright, looking at number 7. We have all three sides for both triangles. So we're shooting for side, side, side similarity. Let's see. In the top triangle, 84 is the biggest. In the bottom triangle, 30 is the biggest. So if these are going to be similar triangles, these are the two that would be corresponding sides. So I'm just going to do top over bottom. So I'm going to do 84 over 30. Doesn't matter which way you do it, as long as you do it the same way all three times. If I do top over bottom, I have to keep doing top over bottom. If I do 30 over 84, then I have to do, bottom over top every time. So anyway, 84 over 30 is going to reduce down to 14 over 5. So we've got 14 over 5. So let's see if they all reduce down to 14 over 5. Now let's switch over to the smallest of the sides. So 42 is the smallest, and 15 is the smallest. So those should be the ones that are corresponding. So let's try it out. Let's try 42 over 15. Let's see what we get. We get 14 over 5. Once again. So far it's looking pretty good. But we have one more to try before we can call them similar. And of course, now I'm talking about the 70 and the 25. So let's do 70 over 25 and see what we get. 14 over 5 once again. Okay, so since they are all the same ratio, that means this will be definitely congruent, yes, by side, side, side similarity. And now we can go on and make our similarity statement. So triangle TUV is similar to triangle. Let's see, angle T is first. Notice how angle T is between the blue and the green. So that's going to match up with angle Q, which is also between the blue and the green. Okay, so I'm going to list angle Q next. Now, I keep mentioning these colors because I have easy access to colors on this screen. But you're sitting there with your pencil, your number 2 pencil, and you don't have the color. Well, I do have students that will bring colored pencils to class, and they will use them on their tests and quizzes. So I'm going to encourage you to do that. I think it gives another dimension. There's just another way to help you see what goes with what if you can do it in color. So bring some colored pencils with you, or markers, highlighters, or even if you're just using a pencil and a pen, you know, that's colors. Maybe you could just get a blue pen, a black pen, and a pencil. That's 3 colors right there. Alright, anyway, so next is angle U. Angle U is here between the red and the blue. So angle U is going to correspond with angle R, which is between the red and the blue. So I'm going to put angle R next. Angle S is the only angle that I haven't done yet, so that has to be last. Okay, looking at number 8. I feel another no coming on. It's almost exactly like a problem that we had. It's almost the same problem as the problem number 5. We got a bunch of angles given, but these 2 angles up here, none of them are the same as this one down here. So even though I know that these angles are the same, one angle being the same is not enough. Nobody is proven to be the same as angle C. So this is just a no. Alright, at least it's quick. Number 9. Well, this is also going to be quick. This one is going to be a yes, and it's going to be yes because of angle similarity. Obviously, we've got the one angle right here, the 61 and the 61. But guess what? We've also got this angle right here because vertical angles are equal. So that's 2 angles. That's angle, angle. So they are similar. And we can go ahead and say the similarity. They listed angle H first, so angle H will match itself for both triangles. Then they have angle G next. Okay, so angle G, of course, is going to match with angle T because they're the 61s. Okay, and that leaves angle S is the only one that we haven't used yet. So there's number 9. Let's take a glance at number 10. What do we have? Look, we have 2 sides and the angle in between. And then over here we have 2 sides and the angle in between. So once again, we are shooting for side angle side similarity. Last time we went for this, our heart was broken. It didn't work out. Maybe we'll have a better outcome this time. We can only hope. So let's see. Looking at these sides, 18 is the bigger side up here. Down here, 42 is the bigger side. So if we do 18, I'm just going to do top over bottom. So that'll be 18 over 42. Okay, that's 3 over 7. All right, will we get 3 over 7 again? Obviously, the remaining sides to correspond are these ones right here. Again, doing top over bottom, 9 over 21. All right, now obviously I could do this in my head, but I just want to, for those of you who are weak at your arithmetic, I want you to know that you can rely on your calculator if you need to. So that's 3 over 7 again. So there you have it. Both pairs of corresponding sides are proportional. They gave us the same ratio. And of course we have the angle in the middle, 76 and 76. So this is going to be a yes. So we can say yes, these triangles are similar because of side angle side similarity. Kabam. Just going to go ahead and get that in there. So now we can go ahead and say our triangle similarity. So what do we have here? Angle F is first. Angle F is the one with the 76 on it. So we're going to say angle U because that has a 76 on it. And then they have angle G. Okay, angle G is the one that's next to the red. Okay, so angle V is the one that's next to the red. So I'm going to put V next. Okay, so we have used U and V, so W is the only one left. So there you have it. Okay. Number 13 and 14. Find the missing length. The triangles in each pair are similar. So we know they're similar. We're told that they're similar. We just need to find the missing lengths. Okay. So looking at the 28 and the 42 would be corresponding. You can just tell by the shape and how they match. So the 28 and the 42. So okay, so I've got 28 over 42. And of course that reduces down to 2/3. Okay, so 2/3 is the scale factor for this pair of triangles. So this is my scale factor. Okay, that's important because now that I have the scale factor, if these are similar, any pair of sides should simplify down to that same scale factor. So if I go ahead and do the other pair of sides, I should be able to set it equal to the scale factor, 2 over 3. Okay, so as I look at my question mark and my 33. Now I did top over bottom, so I need to do top over bottom again. So I'm just going to use question mark as a variable like they did. So question mark over 33 should equal the scale factor. So if I cross multiply, okay, and remember that works like this with the diagonals. Okay, so that's going to give me 3 question mark is equal to, and then 2 times 33 is 66. So if I divide both sides by 3, okay, that's going to give me the question mark. So the question mark side should be 22. Okay, find the missing length. So in this case, the missing length was 22. Alright, last problem, number 14. Alright, so we have to be careful. And this problem is a little bit tricky because we have to decide if the 60 is going to correspond with the 130 or if the 60 is going to correspond to 117. And it's not 100% obvious because you could see it as sort of a rotation, where maybe this K is going to rotate and map onto the T. Or you could see it as more of a reflection, like a mirror, where the 60 is going to map onto the 130, and the question mark is going to map onto the 117. Could be more of a reflection. All right. Now, normally we say the drawings are not to scale. So the thing that I'm going to use to help make the decision sort of goes against that, because I'm going to use the lengths that the way they look in the picture. So with nothing else to go on, that's all we can, that's all we can do. So looking at the 60 and the question mark, which one of these two sides appears to be bigger, the question mark or the 60? Okay, the 60 side appears to be the longer side of the two. So obviously between the 130 and the 117, 130 is the longer side. So based on that, assuming that 60 is in fact the longer side the way it looks on the paper, then these should be the corresponding sides. They're the two longer sides. And similarly, the question mark here, which I will end up calling X, will be corresponding sides with the smaller side of 117. So if I set up my proportion, it's going to look like this. If I do top over bottom, so that'll be like X over 117 should equal, doing top over bottom again, 60 over 130. Now this 60 over 130, that's my scale factor. I like to reduce those whenever I can. So 60 over 130. Okay, that reduces down to 6 over 13. So you don't have to do that, but I like to do it that way. So you do what you want to do. But so I prefer to work with smaller numbers. So this becomes X over 117 is equal to, I forgot what I put, 6 over 13. So then I would cross multiply from there. So of course I've got my 13 and my X. So that's 13X equals, and then I'm dealing with my 117, right, and my 6. So 6 times 117. So that's 702. And then just divide by 13, and that should be our answer. Okay, so 702 divided by 13. I've got 702, so I can just do divided by 13, and that's 54. Okay, so 54 is the missing side. Alright, so that's it. That's a nice little review of how you work with similar triangles.